Motion and movement programming is essential for game development because it contains foundational theories and techniques to implement proper game mechanics and entities' behaviors. There are 6 common motion types in game programming. They are jumping, bouncing, easing, swinging, running with frictions, and elastic. In the first part of the series, game motion programming with Java and libGDX, let's explore the swinging motion. The theory I present in this video is universal, and you can use any code-centric frameworks like libGDX, modern games or lib2d to implement them. In this video, I'm going to use Java's libGDX to demonstrate the technique. A swinging motion is a kind of rhythmic motion where an object oscillates between 2 endpoints. This kind of motion is quite common in games to emulate certain behaviors of the entity, such as a flying beam motion or a floating car motion in the example. In this 3D shooting game, all the hellkits are floating up and down at their positions. In this breakout game, all these blobs have glowing lights with varying and rhythmic intensity. There is a few techniques to achieve this, let's discover them. Number 1 is boundary checking with directional flag. The simplest approach is to use a directional flag with the values of 1 or -1 to store the entity current moving direction. Then, if the entity goes out of the specific range, you flip the flag. Here's the code sample for the algorithm. You have px in the current horizontal coordinates of the beat, which increases or decreases based on the value of the direction variable. If bx goes up range, we invert the directions and also push the beat in a new direction so it stays within the range. The same mechanics applies for the cloud entities here, but in the vertical direction. This is the most straightforward method, but also the most verbose, because you have to use a lot of variables to accomplish a rather simple task. Number 2 is to use trigonometry function. Alternatively, you can model the entity position as a sine or cosine function of time. As you can see, this is much cleaner because trigonometry function is periodic and the function output is constrained. As the time goes on, the values always varies in a predefined range, so you don't have to keep track of the several variables and manually flip the switches like the previous method. And the code above become this one-liner. In this code, B range and cloud range are equivalent to the function amplitudes, which specify the function maximum and minimum values. To change the moving speed, you can simply increase or decrease the multiplier inside the function parameters. This effectively adjusts the oscillating frequency of the sine function. And that's it. Now you know how to program swinging motion in game. I hope you enjoyed the tutorial. See you next time.